Welcome to Day 19. Today we tackle one of the most important topics in all of AI, bias and fairness. Here's the uncomfortable truth. AI systems can be unfair. They can favor one group over another, not because someone programmed them to, but because they learned it from us. A model can screen résumés, score loan applications, or flag faces, and quietly treat people differently based on gender, race, or age. Today we'll understand where that bias comes from, see it with our own eyes in a real demo, and talk about how the field is working to make AI fairer. Let's get into it. Let's start with the single idea that explains almost everything about AI bias. A model is a mirror. It learns by absorbing enormous amounts of human data, text we wrote, decisions we made, photos we took. And human data carries human history, including all of our imbalances and prejudices. So when the model reflects the world back to us, it reflects the unfair parts too. The AI isn't inventing bias out of thin air. It's picking it up from the examples we handed it. Keep that mirror in mind, because it's the key to everything that follows. So let's be precise about what bias means here. It's systematic unfairness, the model treating one group of people worse than another in a consistent way. The crucial point is that nobody usually sets out to build this in. It's learned from data. And it doesn't stay abstract. It shows up in real decisions that affect real lives. Who gets an interview? Who gets a loan? Who gets flagged? And remember, the model has no intent and no malice. It doesn't dislike anyone. It's just repeating statistical patterns it found in the data, even when those patterns are unfair. Here's what that looks like in practice. And these are not hypotheticals. They're patterns researchers have documented in real systems. Feed a model a strong resume, and it can quietly downrank a candidate because of the name or wording associated with a group. Feed it a loan application, and it can deny people at higher rates for reasons tangled up with race or gender. Give a facial recognition system a face, and studies have found it misidentifies some groups far more often than others. Same model, same code, but the outcomes are not equal. That gap is what we mean by bias. So where does it actually come from? A few big sources. First, the training data reflects a world and a history that already contained bias, so the model soaks it up. Second, underrepresentation. If a group appears rarely in the data, the model learns them less well and performs worse for them. Third, we often train models on past human decisions treated as the correct answer. But if those decisions were unfair, we're teaching the model to copy that unfairness. And fourth, feedback loops. A biased model shapes new data, which trains the next model, amplifying the problem over time. Now let's stop talking about bias in the abstract and actually see it in numbers with real code. We're going to use word vectors, the same technology from our embeddings lesson, where each word becomes a list of numbers learned from human text. Because those numbers come from how we actually use words, they quietly encode our associations. And with a little vector math, we can pull those associations out into the open. What comes back is uncomfortable, but that's exactly the point. You can't fix a bias you refuse to look at. Here's the whole demo, and it's short. We load a real, public set of word vectors trained on billions of words of human text. Then we ask it analogies using simple vector math. Man is to doctor as woman is to what? We just add and subtract the word vectors and ask for the nearest word. This is the exact same trick that gives us king minus man plus woman equals queen. There's nothing rigged here, no bias we typed in. We're simply asking the data what associations it learned. Let's run it and see what the model gives back. And there it is. Man is to doctor as woman is to nurse. Man is to programmer as woman is to prodigy. The model learned these associations from the way people have written for decades. Doctors described as men, nurses as women. Nobody typed these stereotypes in. They were sitting inside the data all along, and the vector math just surfaced them. This is a real, well-known result, and it's a perfect illustration. If a model learns from biased text, it will quietly carry that bias into everything it does, from search to hiring to translation. So here's the heart of the lesson. Bias in, bias out. A model is only as fair as the data it learned from and the choices the people building it made along the way. That's actually empowering, though, because it means bias isn't some mysterious ghost in the machine. It has causes we can find and choices we can change. If unfairness gets in through data and design, then better data and better design can help take it back out. Which brings us to the most important question: what do we actually do about it? The good news is there's a real and growing toolkit for this. First, be deliberate about data. Seek out representative, balanced examples so no group is an afterthought. Second, and this is huge, measure fairness. Actually test how the system performs for different groups instead of assuming it's fair. Third, audit. Evaluate systems before you ship them and keep watching after, because bias can drift. And fourth, keep humans accountable, especially for high-stakes decisions like hiring, lending, and justice. A person should be answerable for the outcome, not just the algorithm. Let's lock it in. AI learns bias from human data. It mirrors us, the good and the bad. That bias isn't just words on a screen. It shows up in real decisions that shape people's lives. But it's not invisible or unfixable. We can see it and measure it. We literally just did with a few lines of code. And building fairer AI is a solvable engineering and ethics problem. It takes better data, honest testing, ongoing audits, and real human accountability. Fairness isn't automatic, but it is absolutely achievable when we choose to work at it. So that's bias and fairness in 5 minutes. The big takeaway: bias in AI is learned from us, which means it's not destiny. It can be measured, challenged, and reduced. As AI makes more decisions in the world, being able to spot unfairness and ask the hard questions is one of the most valuable skills you can have. Tomorrow we shift gears to something exciting: generative AI, the technology behind AI that creates brand new text, images, and more. It's going to be a fun one. I'll see you there. And that's bias and fairness. If this made AI a little clearer, do me a quick favor: hit like, drop a comment with your thoughts, and subscribe so you don't miss tomorrow. We're building real AI understanding one day at a time, and I would love to have you back. Tomorrow, generative AI, how machines create. See you then.